Hello, this is James Cook at the University of Maine at Augusta, and today we are going to complexify social networks just a little bit by talking about the distinction between one-mode networks and two-mode networks. So, what is the distinction between a one-mode and a two-mode network? Well, the word mode might make you feel a bit of panic, like this is a highly technical term, but it really isn't. A mode is just a kind of an object in a network. So one-mode networks have one kind of object. Two-mode networks have two kinds of objects. That's the only distinction between the two of them. It's simple, just like a social network is simple. So when we think about one-mode information in a network, we're thinking about ties between nodes. There's just one kind of object in that network, nodes, and their relationship to one another. A two-mode kind of information in a network involves just a little bit more complexity, just two kinds of objects. Now we have nodes, and the things nodes belong to, the things they're affiliated with, the memberships that those nodes have in events, participating in events, in organizations, being members of organizations, or actions, taking part in an action. Those events, those organizations, those actions, groups, you might call them, going to a play, having seen a movie, having voted in an election. Those are all affiliations that nodes can have to larger objects than them. It connects, if you want to think about it from a larger point of view for a moment, it connects the micro-social aspect of a social network to the mesosocial, that is not completely big, but a lot bigger, the mesosocial world of groups, organizations, institutions, and activities that make up the interesting bits of a society. That's the only difference between one-mode and two-mode networks. Okay, it's just kinds of objects there are. How many? One or two? So, if we're thinking about a network, one way to represent a network is by a matrix. And a two-mode matrix is called an affiliation matrix. Why? Because you have two kinds of objects, and one of them is a node, and the other is the affiliation of the node with an event or an organization, a group, something like that. That's why it's called an affiliation matrix. And if you have two kinds of objects, how would you represent that in a matrix? By moving away from the one-mode convention of a matrix, which says, oh, the rows and the columns are the same, and we're looking at the relationship between two nodes. No, we're not looking at that anymore. In a two-mode matrix, the rows and the columns are different. So now here the rows may be people, they may be the nodes, and in this case we have 4 columns, and each column is what? A student organization at a university. Those student organizations might be student government, the tennis team, the college Republican club, and Campus Crusade for Christ. This is completely made up information, okay? But go with me here. So sometimes it's good to start with a hypothetical example. So if the rows and the columns are different, well, what do these ones and zeros mean now? It's not about relationships between nodes. It is whether or not a node is affiliated with a student organization. So let's get very explicit here. Alice, if you take a look at the row for Alice and you run across, you'll notice that there's a 1 for Alice and student government. That means Alice is a member of the student government. There's a 0 for Alice and the tennis team. Alice hates tennis. She's never really been into it, and she wouldn't join that stinking team anyway, right? There is a 1 for Alice and the college GOP, and a 1 for Alice and Campus Crusade for Christ. So we know Alice is a member of the student government. She is a member of the college GOP. She is affiliated with the Campus Crusade for Christ, but not the tennis team. Well, we could do that same report for not just Alice, but for Ben, for Carl, for Deb, for Eric, for Flo, and for Glenda. And notice there's a lot of information to report. It took me a minute or two just to talk about Alice. And heck, there's 7 times as much information because there are 7 nodes here. And yet it's a nice compact package. Here we have membership data for 7 whole students in 4 organizations. The 2-mode matrix, the affiliation matrix, is our way of doing that. To give one more example, just in case you need a little cementing, let's think about Deb. Take a look at Deb for a moment. Can you figure out on your own, pause the video, what groups Deb is a member of? Okay, so you should have been able to figure that out. Deb is a member of the college GOP and also of the Campus Crusade for Christ, but is not a member of the student government or the tennis team. One more challenge for you. There's more information you can get from this matrix. How many people are in student government? Do you see it? Add up the ones going down the column for student gov. 4. There are 4 people in the student government. Alice, Carl, Eric, and Glenda. Adds up to 4. There are 4 people. We could go add across. How many student organizations is Ben involved in? How many is he affiliated with? How many is he a member of? 1. Only the tennis team and none of the others. And we can see that by adding across. So this is a mathematical object, okay? And when I say mathematical, it doesn't have to mean hard. The math of this is pretty easy. If you can add ones all together, you can do this, which makes it a very powerful object. The most powerful mathematical objects, I think, are the simplest ones, the ones that everyone can see and understand, but that represent an important idea. I get excited about this. And the reason I get really excited about this is because Ron Breiger, in 1974, Social Forces, The Duality of Persons and Groups, wrote an article that talks about taking this 2-mode information and thinking about it. And thinking about it to make 1-mode networks from the 2-mode data. Let's talk about that concretely, okay, using this example. Up on top, we have a 2-mode affiliation matrix. How do you know it's our 2-mode affiliation matrix? Well, partly because it looks pretty familiar. It's from our last slide. But also you can look and you can say, are the rows the same as the columns? No. They're not even the same kind of things. One is a social object. What kind? A group. What is the other kind? People. Oh, the nodes in a network. 2 kinds, 2 modes. But at the bottom, check it out. There is a 1-mode adjacency matrix. Whoa. How do I know it's 1-mode? Well, first key is that everyone in every row and every column that's labeled is a person. And they're the same people. So this seems to be your classic social network adjacency matrix. Who is adjacent to whom? Who is tied to whom? However, the data in it are a little unusual. Let's look at those. Look at those cells. They're not 1s and 0s, indicating the presence or the absence of a tie. There are 0s, yes, but there are 1s, but there are also 2s and 3s. Whoa, okay. So what does that mean? It means that some ties are stronger than others. And what do those numbers mean? Well, let's go through a few examples. Because what that adjacency matrix at the bottom is the transformation of the two-mode affiliation matrix at the top, going from top to bottom. What does that bottom matrix represent? It represents the overlap in groups. How many groups does one node share with another? How many memberships does one node share with another? How many affiliations does one node share with another? Let's go through a few examples and think about how we would move from top to bottom. Well, one thing we can do is we can think about the diagonal of this network. What is a diagonal? It is a node's association with itself. How many groups does a node share with itself? Well, the number of groups that the node is a member of. So let's take a look at the top matrix. Alice is in the student government, the college GOP, and the campus crusade for Christ, right? She's in 3 groups. She shares 3 groups with herself. Oh, okay. That's just a complicated way of saying she's in 3 groups. So notice she has a 3. Notice Ben in the diagonal, right? The diagonal is the set of cells that in which a node is referring to itself. So going from Alice to Alice and then Ben to Ben, we see a 1. What does that mean? Oh, Ben is only a member of one group. Remember the tennis team? We can see that up top. If you need to follow through, go back, rewind, or pause the video, and you can see that for yourself. Looking up at the top, there's a 1 only for Ben in the tennis team. So Ben shares 1 group with himself. Oh, this is pretty straightforward. What about Carl? Carl shares 2 groups with himself? Yes, the student government and the tennis team. And so you could go on and on. Deb is a member of 2 groups, so she shares 2 affiliations with herself. Eric, the same, member of 2 groups, 2 affiliations with himself. Flo is only a member of 1 group, like Ben. She's only on the tennis team, so she only shares 1 with herself. And Glenda shares 3 with herself because she is, like Alice, a big joiner. She's joined 3 student organizations. In fact, the same 3 that Alice has joined. Okay, so what does that mean? It means that we understand the diagonal. It tells us something useful. It tells us who is a member of more organizations. But now let's go off the diagonal from Alice to Ben. How many groups, how many affiliations do Alice and Ben share? None. That's because while Alice is a pretty big joiner, she's a member of the student government, the college GOP, and the campus crusade for Christ, the one group she hasn't joined because she hates tennis is the tennis team. She's not on the tennis team. There's a 0 there for her. But that's the one group that Ben has joined. So there's a 0 there. And in the bottom matrix, right? Alice and Ben share no groups. If you don't share any town or any group membership or any university student membership with someone, how likely are you to get to know that person? To bump into them. You're not going to bump into them because people meet each other in groups. This is Ron Breyger's point in that 1974 article, The Duality of Persons and Groups. So when we say Alice and Ben have a tie of value 0, it means something. The 0 means they have no group memberships together. And it also means that we predict that they are going to have a very weak tie. In fact, so weak that we know of no context in which they would meet each other. It's very unlikely that they are going to share a friendship with each other, that they are going to share needles with each other, that they're going to share diseases with each other, cough on each other. If we're thinking about an epidemic network, right? So these things matter. Who's going to spread diseases to whom? our bottom matrix might tell us. Alice and Carl might be a little bit more likely to form some kind of connection. Why? Because they are Alice to Carl or Carl to Alice. It's going to be symmetric, you'll notice. They're members of one group together. Which group is that? The student government. If they're members of the student government together, that means that they have to listen to the same interminable reports every Friday when the student government gets together. It means they hang up signs together. It means they're doing things together that student government members do. That's great. So that's a chance for them to get really involved. But hang on. Are Alice and Carl going to be best buds? Well, maybe not, because take a look at Alice and Deb. Now, Alice and Deb, right, if we take a look at the top matrix, the affiliation matrix, the two-mode matrix, we can see that Alice and Deb are members of two groups together, the college GOP and the campus Crusade for Christ. Now, there's two sets of meetings that they sit together on. That's two sets of late-night banner hanging for some kind of activity on campus. That's two kinds of t-shirts that they share, and they have to wear the same kinds of t-shirts because they're members of the same group. That's twice the amount of opportunity for them to form a friendship. Now, Alice and Deb are really close, and Alice and Eric we would expect to be sort of close too. They also share two groups, but Alice and Glenda, they share each of their group memberships with one another. They actually have the strongest connection in all of the network. They have the largest number of groups shared with one another. Who are the best buds going to be in this network? If we had to guess, Alice and Glenda. Even if they're enemies, they're going to have to be frenemies because they're going to have to interact with one another. They're doing so much together. They certainly are going to know about each other. And they probably have a lot of interaction with one another, too. We can find this out just by getting membership lists. Wow, okay? Think about that for a minute. Two-mode affiliation data is invaluable because it really does give us a glimpse into who is being shoved together with whom, who is likely to form a tie with whom, but it's really easy data to get. It's easy information to get. Okay. Now, you could go through, and I encourage you to pause this video and think about a few more examples. Let's think about Eric and Deb. Okay? Pause the video. Tell me how many groups Eric and Deb are joint members of, what group that is, what groups that they are, and what their tie strength is. Okay, pause. Okay, so we had Eric and Deb. Eric and Deb are in one group together, the college GOP, the college Republican Club. So they have a tie strength of 1. Okay, and that is better than 0, but it's not 3. So they're moderately tied to one another, we might say. Okay, if I was selling you Ginsu knives, I would say, but wait, there's more, because there is more. How much more? Well, there's twice as much, because we cannot just talk about connections from student to student, person to person. We can flip the whole operation around and talk about connections between groups. What I mean is this. If groups connect people together, people connect groups together. Think about it this way. Let's imagine the college GOP is having a little bit of a crisis. Somebody is challenging the bylaws, which happens if you're in a college GOP group or any college political group. Somebody's going to say, "Order, I challenge the bylaws. I say we need to change the bylaws and kick out the current president." And all of a sudden everybody in the club is saying, "What do we do? What do you mean kick out the president? Is there a precedent for such a thing?" At that moment, is there a precedent for such a thing? Has this been done before at the university? What happens? Okay, freeze. If you're in that group, somebody's going to raise their hand, right? Somebody's going to raise their hand and say, oh, I remember how this was handled. We had something happen just like this in what? Another group. What kind of group? Maybe Campus Crusade for Christ. Maybe somebody tried to get rid of the leader of the Campus Crusade for Christ last year. And how did they handle it? Well, who would know? Somebody who was on the Campus Crusade for Christ. And check this out. If you compare the columns, looking at our two-mode matrix again, we know that there are 3 people who have some knowledge of how they handled it in Campus Crusade for Christ. That means Alice, Deb, and Glenda, right? Now, Eric is in college GOP, but he's not in the Campus Crusade for Christ, so he doesn't know about that. But there are 3 people who do. What does that mean? That you have 3 sources of information who might remember how it was handled last year in the Campus Crusade for Christ. So what does that mean? It means that the college GOP is likely to handle it the same way, right? On the other hand, if the tennis team had this situation, right, maybe the tennis team had the team captain, was replaced in a late night kind of purge or something. I don't know, tennis politics, right? So, but is the college GOP going to know about that? Are they going to know about how the tennis team handled that? No. Here's why. Look, compare that second column, the tennis team membership, and the college GOP membership. There's nobody who is on the tennis team who is also on the college GOP. Nobody. So that information, that experience, that knowledge of how to do something in a group is not going to move from the tennis team to the college GOP because nobody is there to tell the story of what happened on the tennis team. So, pardon. So what that means is that if the college GOP has somebody do a leadership challenge, they're much more likely to go the way that the Campus Crusade for Christ does, and much less likely to go the way that the tennis team does. How do you represent that? You represent that by saying the college GOP and the Campus Crusade for Christ are tied more strongly to one another, right? So ideas, ways of doing things, practices are going to move across the relationship between the 2 groups more freely. There is no relationship, on the other hand, between the tennis team and the college GOP. Oh, look at our one-mode adjacency matrix, which talks about the relationships from groups to groups, down at the bottom. Tennis team to college GOP, tie strength of 0. College GOP to Campus Crusade for Christ, tie strength of 3. What does that mean? Number of members held in common. There are 0 members of the tennis team who are also members of the college GOP. There are 3 members of the college GOP who are also members of Campus Crusade for Christ. And so there's a 3 in that cell. What about the diagonal? Okay, the diagonal again is telling you something about the relationship between one group and itself. So when Student Gov has a value of 4 in the cell that relates it to Student Gov, it means that Student Gov, student government, shares 4 members with itself. But it only shares 1 member jointly with the tennis team. 1 member they have in common. That's what the tie means here. What is that member? Can you see it? It's Carl. Carl is on the student government and the tennis team. Hey, good to know. What else do we have here? Is there any other strong tie? Oh, look. College GOP and student government. 3. Who are those members? Alice and Eric and Glenda. Okay. So the college GOP knows a lot about what happens in student government. Okay. It also knows a lot about what happens in the Campus Crusade for Christ. The student government and the Campus Crusade for Christ are a little bit less familiar with each other. They only have 2 members in common. Those 2 members are, can you find them? Yeah, Alice and Glenda. Okay, so now we've gone from 2-mode affiliation matrix to 1-mode adjacency matrix. But it's a different one. It's the relationships between groups. So you want to know which groups are close to each other. You want to know which ones are far separate away from each other. Now you know. Pretty cool. All from 4 membership lists, right? You can get all this information.